Hello Year 11, welcome to Revision Week 25. This week we're looking at searching algorithms and specifically the linear and binary search. Make sure you have your revision sheet in front of you ready to follow along. Revision sheet 25. Okay, today we're going to look at how algorithms can be used to search for things in a list. So remember, an algorithm is just a set of steps to solve a problem or a task. So searching algorithms are an algorithm in a set of steps on how to search for items. Take this list of random numbers, for example. How could we search to see if the number 21 was in this list? Bearing in mind we don't know what the numbers are. Well, I could start at the first item and check it. I could start at the last item and check it. I could choose the middle item and check it. I could go through the list one after in order. The way we do this is the algorithm, the set of steps. For example, it was actually this value here, 21. If I started at the beginning, I'd have had to go 1, 2, 3, 4, 5 items to check it. If I started at the end, I'd started 1, 2, 3 items. So depending on how you check the list can take how quickly an item can be found. So there are two algorithms that you need to know about and be able to do for this exam. The linear search and the binary search to find items in a list. Linear search. Well, say we were looking in this list here, to find if the letter D is in this list. How would we do it? Well, we would start at the first item in the list, which is A. We would compare it and see if the item equals D. Well, clearly it doesn't. But if it was found, we'd stop there and we'd output it. But it's not. So we're going to move to the next item in the list, which is F. And we would compare that to D, and it's not the same. So we keep moving through the items in the list, one after the other, comparing the item to the item we're looking for, D, until either we find the item or we reach the end of the list and the item is not there. So in this case, A is not equal to D, F is not equal to D, B is not equal to D, E is not equal to D, D is equal to D, item found, we stop there, and the search has been completed. Linear search. Going through the items one after the other in a line, linear, until you find the item or the item is not in the list. So, starting at the first item, comparing with the item, and moving through the list one after the other until the item is found or you reach the end of the list. What are the benefits of this? Well, this algorithm is very simple and easy to use. It's simple to carry out and simple to program. And it can be used on any type of list. The items do not have to be in order. However, not very efficient for large lists. If it is a long list, you would have a lot of comparisons, a lot of checks to go through the list. If the item was the very last item in the list, it would take a long time, or even if the item was not in the list at all, you'd have to search through the whole list to find it. So it is not good, efficient for large lists. So, on your sheet, do this with me now. Have a look at the example we have and complete this with me, or pause the video and try it yourself first if you'd like. So having a look here, we've got a list of items. We're going to find the item G. Carefully describe the steps. Describe the steps. Okay, with words, how would we do this? Well, we would start at the first item, A, or index 0, and compare it to G. The item is not the same, so we move to the next item, F, and compare it. And we keep moving to the next item and comparing it until either the item is found or we reach the end of the list. That is describing how we would do a linear search with words. Describe. If you are asked to carry out a linear search, you simply have to do the search. In this case, we are finding the item E. We start at the first item. A is not equal to E. Next item, F is not equal to E. B is not equal to E. E is equal to E. Item found, and we stop. So describe, make sure you use words in describing what you're doing. If it just says carry out or show, you would just do the algorithm. Advantages, very simple and easy to use, can be used on any type of list. Disadvantages, not very efficient for large lists. Checking your sheet, correcting, and filling it in. Okay, so we've looked at linear search. We're now looking at binary search. So binary search is very different. In a binary search, we say if we wanted to find the letter G in this list of letters. So the first thing you'll notice is the items in the list have to be in order. They have to be in order, numerically or alphabetically. We start by finding the middle item in the list. In this case, the middle item is F, and we compare it to G. How do we find the middle item? The simple way of doing it is by taking the total number of items plus 1 and then divide by 2. So 11 plus 1 divided by 2 gives us 6, or the sixth item, and the sixth item is F. Now if you compare F to G, F is lower or less than G, so I know that F and everything to the left side of the list is not suitable, so we remove it. And then we write out our new list, GHIJK. We do the same thing again. We repeat the process. Find the middle item, which in this case is I, or 5 plus 1 divided by 2, which gives us the third item. I is bigger than G, so I know that I and everything to the right is no good, so I remove it, write it on the new list, G and H. I do the same thing again, 2 plus 1 divided by 2 gives us 1.5. If it is a 0.5, you round up to the next item, which is 2. GH, H is too big, I get rid of it, and we are left with the item G. Item is now found. So you repeat the process until either the item is found or you get turned to one item and it's not the item we are searching for. How about with a string, a word item? So in this case, let's look for the item Steve in this list. Well, the same thing applies. First thing, we find the middle item, Lara. Why is Lara the middle item? Because there are 9 items plus 1, 10 divided by 2 gives us the fifth item. 1, 2, 3, 4, 5. Fifth item. Lara is less than Steve alphabetically. L is before S. So we remove Lara and everything to the left in alphabet. Our new list then becomes Nora, Steve, Trevor and Warren. We find the middle item. In this case it's going to be Trevor. Why? Because 4 plus 1 divided by 2 gives us 2.5 and we round up. So Nora, Trevor, Steve, the third item here. Trevor is bigger than Steve, so we remove Trevor and Warren to the right and we are left with Nora and Steve. We do the same thing again. 2 plus 1 divided by 2 gives us Steve is the next item, middle item. Steve is the item we're looking for. Item is found, so we don't have to go any further. So, binary search. Find the middle item. If the middle item is found, you stop. Otherwise, you get rid of the side of the list that does not contain the item. Repeat the process until the item is found, or you get to one item and there is no match. Benefits of using binary search. It is quicker or more efficient for larger lists. There are fewer steps involved. And the negatives of it, the items must be in order, alphabetically or numerically in order. So, do this with me on your sheet now, or pause the video and try yourself first and check if you would like to. So we have a list of items here, A, B, C, D, E, F, G, H, I, J, K. We're looking for the item C. Now I can see and you can see that it's there, but for a computer to find it, doing a binary search, they would do this. Describe with words. Find the middle item in the list and compare it to the search item. Well, in this case, the middle item would be the sixth item, F. We compare the middle item F to the item C. If it's not the item, keep the side of the list that contains the item, discard the other. So in this case, we would write out the new list, which would be, we're looking for C, so we'd be A, B, C, D, E, and then we'd repeat the process until either we find the item or we get to one item and it's not there. That is describing how to do it. If you were asked to carry out a binary search, it means simply do the search. So in this case, if we were asked to carry out a binary search to find the item E, how would we do it? We'd find the middle item. In this case, the middle item is the 6th item, or F. The number of items plus 1 divided by 2 gives us the 6th item, F. Or F is greater than E in the alphabet. So we know that F and everything to the right is no good. We get rid of it, discard it. Our new list is A, B, C, D, E. We then repeat the process. Find the middle item. There are 5 items plus 1, 6, divided by 2. The third item is C, A, B, C. We know that C is less than E in the alphabet, so we get rid of C and everything to the left, and we are left with D and E. Finally, again, we find the middle item. There's only 2 items, so 2 plus 1 gives us 3, divided by 2 is 1.5. We round up to the second item, and the second item is E, and we found it. So the process of finding it, find the middle item, compare, get rid of the side that doesn't contain it. Advantages: more efficient for large lists, but however disadvantages: the item must be in order. Now to finish off with on this lesson, I've actually given you some practice ones on the back of the sheet that you can have a go at. So you can pause the video and have a go at these now. I've got one that says show, one that says describe for each the linear and binary search. You can pause the video now and have a go at these to practice if you'd like. Okay, and to check your answers, once you've done the practice, we've got the steps of showing how to find the item butter, comparing until you find the item, and describing to find the value MNT, and a binary search to find the item 21, and describing to find the item cat in the list. Checking your answers, read through, and improve if necessary now. And finally, as always, go to LearnCumDean, revision quiz 21, check your answers, correct if necessary. You're aiming for 100%, and I will see you in lesson. Goodbye.